Hi, it's Tim and welcome back to the corner. You might recognise this +4 that is still on the bench. In fact, it's been less than a week since we built this power supply for it and the dreaded thing has happened. So what it does is, and I'll show you this very quickly. That. So let's figure out what's wrong. So I've taken the lid off and our three main suspects are going to be the TED chip under here, the 8501, which is here, the RAM, and of course the various MOS logic chips. So let's look to see what we've got. And I've got the scope switched on, power it up. You can't see the screen, but the screen is black. So let's just check. Pin 5 is VCC on here. 1, 2. So 5 volts is 5 volts. Pin 40 is reset. Let's just have a look at that. That's high, that's as it should be. Pin 1 is the clock in. That is clock in. Just look at the address line, 6789, 1, 2. That's kind of doing stuff. 7. And on the other side, we've got the data bus. It's D0, D1, D2, D3. Nothing seems to be hot. Pin 2, that's definitely got stuff on it. Pin 14, that's definitely got stuff on it. Okay, so the RAM's got signals on it. That to me is looking more like the TED. So let's take the lid off and have a look at that. I'm going to turn the power off first. I'd like to thank PCB Way for sponsoring this video. PCB Way make excellent quality printed circuit boards, just like these. These are circuit boards that I've designed myself, submitted the Gerber files. PCB Way have made them. $5 for 10 boards. They also do shared projects just like this or like this. They also do CNC machining, 3D printing, flexible PCBs, PCB assembly. If you want it, they can do it. Check them out, www.pcbway.com. Okay, I've taken the lid off. We've got our thermal sticky pad here. So let's power it back on. Now, according to the circuit diagram, this is the TED here. Clock is pin 14. Feels slightly warm, not particularly hot. Clock in. That should be clock in. That doesn't look particularly clockish. Pin 12 should be phi 0. Yeah, I was looking at the wrong pin. That should be clock in. And that looks clockish. It doesn't look very... Is that high enough? Is that clockish enough? That's the phi 0 out, which I guess is 4 volts, so I guess so. Pin 7 is read/write. That's doing not a lot. Pin 13, that should be colour. All you video experts, does that look right? Pin 23 is Luma. Yeah. Well, nothing's coming out of this TED apart from basically a black screen, which is what we've got, a black screen. Well, look what I've got. It's an 8360 TED, or at least it says it's an 8360 TED. Whether it is or not is another matter. But let's give it a try. So, put my wristy strap on. Okay. There we go. The legs are bent out, so it's either new old stock or a new fake. Got no way of testing it without plugging it in. No, that's pin 0. Whoops. It says Hong Kong. 8360, that can't be a date code. It says 2567. 22. I don't know what that code means. That wasn't particularly a cheap chip. So here goes nothing, as they say. And nothing is going because, of course, it's not powered on. At the mains, right. Here goes nothing, take 2. Yep, exactly the same, black screen. So if that was a genuine TED chip, that wasn't the problem. More thinking. So now it's tomorrow and I am going to try a new thing. Well, I'm going to try 2 new things. The first thing I'm going to try is taking all these ICs out, cleaning them with some contact cleaner and putting them back. If that doesn't work, I have in here a replacement PLA, which is that chip. So this came from myretrostore.co.uk, cost me about £12.50. That will go in there. It's a low profile one so that the case will close and the keyboard will go back on. Because the higher profile ones that are suitable for the C16 are too high on this machine. Right, so let's start with the TED because I can put the original one back. So this is the original TED. Before I do that, I'll put my magic piece of string on. There we go, that's the original back. You stick this into its anti-static. There we go, that can go back into the drawer for another time. This is the 8501. We could give these a little bit of a scrub with a glass fibre pen. Now bear in mind that on these single wipe sockets, it's actually the inside of the leg that makes contact. So cleaning the outside is not going to do an awful lot of good. But we do it just for completeness. I'm going to go through all the chips, not check it after each one, just because that makes life a little bit simpler. This, of course, is the PLA, and that is going to be our next suspect. Okay, let's try it out. There's your answer. So what we're going to do now is change out the PLA and see if that is the problem. Now, if this works, we're going to have to unsolder this and solder this directly onto the board, because otherwise it will still be too high. But we can try it like this for now. There's the notch on the top. Reignite the power supply. 3, 2, 1. Nope. And the output of the TED chip in 23, that's our Luma signal. And that's our colour signal. Ho-hum. Now you might be wondering why there's 2 +4s on the bench. And the truth is, I went out and bought a 1551 disk drive, and this +4 came with it. So I had the brilliant idea of, why don't I take the chips out of this and try them in this? Well, the problem was, this machine doesn't work either. In fact, it has exactly the same black screen problem that this one has. So, what to do? Well, fortunately, fellow YouTuber Steve from 8-Bit Retro Refix, check out his channel up there, volunteered to take the chips and test them in one of his machines. And basically, to cut a long story short, I took all the chips out of these 2 machines, sent them to Steve, he tested them and sent them back, and this is his report.
So, okay, I've got the Commodore 16 out. These are +4 chips, but what I'm going to do is test what I can in here anyway. I think my +4, a lot of them are actually soldered to the board, but I need to strip that to have a look at it. This was one that I just had to hand for the time being. So we're going to check the 8360 TED chips at the moment. So we'll fire this one up, and you can see there it's booted and it's fine. So let's pull this TED out first and let's see what happens with them ones. So here comes the TED. TED's out. So an 8360. So there's one 8360. Let's pop that in there. See if that boots. And it does. So that's got a nice big tick put across there. But that one works. So we know that that TED's up and running. So let's try another TED and see if that works for him. Put that back. And there's got a nice tick on it. There's an 8360, another TED there. Let's have try that one for him. In you go. Does that TED work? Yep, that's another TED that works, so we can put a tick on that one. We've got another one. Yep, we've got another. So put that over there. 8360. 8360 TED. 8360. In you go. Flick the switch again. Yep, that's fired up as well. So it looks like all the TEDs are good. So the PLA for these is a 251641. So we'll try this first PLA. And she blows. Does it work? No, we've got a failure on a PLA. So that one is a big... We'll give it another try. We'll lift her out. Lift it out. Put her back. Just in case it were mucky on the socket or something. There we go. No, PLA bad. So that's one PLA gone. We'll put a big across that PLA. Next PLA. And she pops. And she goes, right way around, flick the switch. And that one works. We've got one good PLA out of that one. Yo! So, okay. That was a bit of a mammoth task. I had to find my power supply for that, and it took me bloody ages. Not that you guys will notice, because it's straight away, bish bash bosh, done. So, let's fire this up first and let you see that the +4 actually does work. There you go. That's working. So we're going to take a look at these CPUs. So let's pull my CPU out. Brand new socket in there because I changed that. So that's mine. This is yours. So we'll go for that in there. We actually go the opposite way around to what the C16 went in. So put the notch that way, which is correct. Flick the switch. That is a dead CPU. And I can't find my marker pen now. That's disappeared. Oh no, there we go. So that CPU is brown bread. We know that. So brown bread CPU. Flick that switch back off. Pull that. Let's try his other one and see if this CPU works. So let's go for it. No. We've got a dead CPU. 2 dead CPUs. What I'll do for you is I'll chuck you a adapter board in. You'll have to write yourself an EEPROM though, but there'll be an adapter board for that. So let's just put my CPU back in here. So, we've tested all them chips. We have got 2 dead CPUs, and there is 1 dead PLA. All the rest of them are working. So I'll get these back into the post for you, and I'll also chuck you in one of these adapter plates so you can use a 6510. You will need an EEPROM. If you give me a nudge, I will send you the EEPROM image so you can burn that off and pop that in as well. If you want to use that adapter plate, or unless you want to buy the chips yourself. But I do know that these CPU chips, the 8501s, are very expensive. But yeah, so you need 2 CPUs and you'll need a PLA as well. So that's all I'm tested for you.
So these are the 2 machines, and these are the chips back. As you can see, Steve has marked these 2 with crosses and this one with a cross, and everything else is ticked. So the problem is we have got no CPUs, because both 8501s, these are the 8501s, both 8501s are faulty. One of the PLAs is faulty, which is okay because one of them works, and I have got this, which is a GAL replacement for a PLA. So this will go in one machine and the PLA will go in the other. But we have a problem with the CPU. And the solution that Steve has come up with is this. This is a 8501 to 6510 adapter, and it comes from myretrostore.co.uk. So a shout out to them. They are not sponsoring this in any way. Basically, you can put a 6510 in there to drive this machine. This adapts the differences between it. So the issue with the 8501 is that they are incredibly expensive, and they are currently, they're about 80 quid each. That's not 18, that's 80 quid each. So I'm not paying 80 quid for a chip, but a 6510 like used in the C64 is about 15 quid, 15, and I've got one here, 6510 dated 2784, and that cost me 15 quid off eBay. And this solution that Steve has provided is basically an adapter that goes from the 6510 to the 8501. The only thing that that does is it loses you the ability to turn the tape motor off automatically. Is that a big problem? As you know, I'm not really a gamer. I tried a bunch of tape games with this machine, and quite frankly they were crap. So the chances of me worrying about that are slim to nil. So I think we're going to put these chips back both machines, and I'm going to build up this and put this 6510 into it. So let's do that. I might well put this in as well and just leave the working PLA to this other machine. We will debug this machine at a later time, so let's not worry about that for the time being. So I'm going to use this one and I'm going to build up this. Let's do it. Okay, these chips are in the same order that they appear inside the case. So this will go in here. That's the TED. CPU does not work. So we can then start fitting the ROMs. There we go. You can possibly see on the screen behind me that I've double checked with a picture of the machine before I took the chips out. So these are the two that we need to replace. I'll stick this back on. Actually, let's get some thermal compound. I've got some up here. This is good old Noctua NT-H1 thermal paste. So I can go on there. And that will basically squidge onto the TED. There we go. So we need to fit this into here. Now if we just plug that in, that is going to be too high for the keyboard. There we go. So then if we plug this back in, you can see that is not going to shut. So that is no good. What we will have to do is take out the socket and solder that directly to the board. And I think we're going to have to do basically the same with this. So I need to figure out which way around that goes. Because if that goes like that, it ain't gonna fit. I'm going to have to check on that. Okay, I've taken the board out of the case. Now I'm experimenting with pointing the webcam down at the board rather than at my face, so we'll see how well that works out. After all, that's much nicer to look at. So I've got a pin header and a 40 pin socket. Now, this is strictly speaking the wrong way round, so on a +4 it should go that way rather than this way, and unfortunately it goes this way. So I think I'm going to have to flatten these capacitors. So what I'm going to do is I'm going to put this into here, like this and like this. And then I can put this on here, and that way it is going to line up, and we are going to know it lines up, and that shows us actually that it does fit quite nicely. But when this is on, I think that is going to be too high. So what we're going to have to do is take this socket out, but we can solder this up first, and that is nicely lined up because we've plugged it in. There we go, so we should now be able to lift this out. Okay, so what we'll need to do is take this socket off, and also the same with this one. Take the socket off and then we can solder this directly on. But first Let us solder the socket onto here. And there we are, that's made. So I'm going to start by adding some solder to these, and then I'm going to use the desoldering gun. I had to change the bit on the soldering iron because I don't know if you can see that. That is very damaged. So it didn't last very long. Let's try and get this last socket out. There we go, that's out. So 2 good removals. I will just give it a bit of a clean with some IPA. Now there are some alternatives to this socket, and basically there's this which converts a 6510 to be an 8501. There is also a device that will convert a 6502 to be an 8501 or a 6510 or a 6510T, which would work in a 1551, or an 8502, which would work in a C128. And there's 2 versions of that. There's one which is just a straight drop-in like this, has some logic on there. Or there's another one which actually has 256K of memory on the underside, and that will turn this into a 256K machine. So I think it might be interesting to try some of those out and see how well they work, what the differences are. If you would like to see that, then please comment in the description below, in the comments below even. Right, so this PLA goes in there like that. Double check we've got it the right way up. The little notch is at the top and the notch on the board is at the top. That's correct. Because we can't socket this, otherwise the keyboard will not fit. There we go, that's the GAL PLA. And now we can fit this notch, notch. There we go, and that's going to be basically the same height as the top of the can, so that should be fine. I'll just do the corners. And once again we push it from the other side. Hear it click. So we know it's in place, and now we can just solder the pins. There we go. So all we've got to do with the strap on is plug the 6510 into the socket, and hopefully this will now work. Shall we plug it in and try it? Okay, the screen is plugged in, there's no keyboard, power is plugged in. This is just going to be a quick test to see if it switches on. So here we go. Look at that! It works! Yay! So let's put him together. Now before we shut it up, there is one thing that I have forgotten to do, and that is, to use this properly we need a different kernel ROM, and the kernel ROM is this one. So the ROMs are basically basic, kernel, function low, function high. These are the built-in 3+1 software, or you could take them out and put anything else in there, of course. So Steve kindly supplied a kernel. It says C16 on it, 6510. Of course, it doesn't matter whether it's a C16 or a C or a +4 because it applies to all the TED machines. So let us take out the current kernel and replace it with a new one. If I can get it in the hole. There we go, it's in the hole. So quickly try it, switch it on. Yep. So the final thing that we're going to do is the diagnostics test. Now Duncan from another YouTube channel has kindly lent me a set of bits. So I have no idea what this is going to do. Let us find out. Here goes whatever. Oh, 6510. Spotted that. So it seems to be saying the keyboard is bad, the joystick. So those are the functions that are driven by this chip and this chip, which are the TED equivalents of the CIAs. These are 6529s. The C64 CIAs, of course, are 6526s. So are these faulty? Or is that something to do with the 6510? I guess we shall find out if we plug the keyboard back in and something into the serial port. Let's do that. So I think maybe with the diagnostic cartridge the problem was to do with connections, because I did try it again and I had more success. Now I've plugged everything back in. The keyboard is connected, as you can see. It's working fine. And I've plugged my Pi 1541, you remember the Pi 1541, we built that, into the serial port. So we can just go directory, let's have a look at something else. I have no idea what any of these things are, so of course this is emulating a 1541, so it is going to take a long time. This doesn't even have the fast serial that a 128 does. I'm not sure, mind you, I don't think that a Pi 1541 actually implements fast serial mode. We've still got that glitch. See what this does. Well, isn't that fun? So this is a +4 back up and running, and we have another +4 to look at some point. If you've got this far, thank you very much. Please give the video a like if you are so inclined, and subscribe if you haven't subscribed already. Check out my Patreon. The list of patrons is on the screen. So thank you for watching. We will look at something else next time. See ya. Bye.